Kia ora, Year 11 and 12. Here are the two excellence questions from question 2 of last year's calculus paper. Okay, so have a good read of this and try it yourselves first. We've got a chemical slowly leaking onto a floor. So we can think about a chemical starting here. Oh, I need a big blob. Okay, so there's my blob, and the chemical is spreading in a perfectly circular manner. No, actually, all we're told is that we can model it with a circle. Okay, so we're given a formula for the area of the circle of the chemical leak, which is pi r squared. And we're told that the radius is given by this expression. So we can straight away write down r is equal to 0.1 t plus 2. So this links the radius with the area. We've known that for a few years. And this links the radius with time. And what we're asked for here is to find the rate of change of the area with respect to time. So we're looking for not dA by dr, but dA by dt. Now that's a bit of an issue because we don't have t in here. So what we have to do is use my link between r and t and substitute in. So we can get on with that, and we'll get this expression for the area in terms of time. Right, I'm going to expand that out. So 0.01 t squared plus 0.4 t plus 4, and now we'll just expand out the pi part. So we get 0.01 pi t squared plus 0.4 pi t plus 4 pi. Now we're looking for the derivative with respect to t, and we can get that now. So we'll go ahead and work that out down here. So dA by dt is equal to 0.02 pi t plus 0.4 pi. So we're almost good to go, but we don't know what t is. So look what we were told to figure out. We would need to find the rate of change with respect to time when r equals 10. But my dA by dt expression is in terms of t. So I need to go back to this and now solve for what time, what t value will give me an r of 10. So we'll do that on the next slide. Okay, so we've got r equals 0.1 t plus 2. We want to know what t value gives me 10. So we get 8 equals 0.1 t. T is equal to 80, and remember that's seconds. Now, we've got dA by dt. That's equal to 0.02 pi t plus 0.4 pi. So that's going to be 0.02 pi times 80 plus 0.4 pi. Now that actually simplifies out really nicely. I know most of you will do that on your calculator, tragically. But if you're doing it by hand, you end up getting 2 pi centimetres squared per second, which is 6.28 centimetres squared per second. So what that's showing us is the rate of change of the area after 80 seconds is an extra 6.28 square centimetres per second. So that's the first of the two questions done. Just one thing to make sure that you're getting confident with is that when I'm working with a rate of change, my answer is going to be given as a rate, and it's per time unit, so that's the per second. And always check the numerator in here. We're working with area, so we want to have centimetres squared. Okay, on to the next one. All right, we've got a function defined by this, and a is a positive number. We need to find the range of values of x for which the function is decreasing. But before I launch into the algebra and the calculus, just have a look at what type of function we've got. Because it's level 2, there are a limited number of situations you're going to see. So this is a cubic, and it's a cubic with a positive coefficient. So it's probably going to look something like this. Now the values there are all wrong, but we can see that we've got, where have we got it decreasing and increasing. Well, decreasing is this bit through here. Okay, so it's going to be between two values, and that's quite important when we get down to the algebra, because it does get a little bit messy. Okay, so now we have to say, what does it mean for a function to be decreasing? So decreasing means that the first derivative, the gradient, is negative. So we're going to start by figuring out what's f dash of x. F dash of x is equal to 9x squared minus 4a squared. And we need to have that be negative. So this is what I've got to solve, and I've got to get values of x. So straight away we get 9x squared is less than 4a squared, and then we get x squared is less than 4/9 a squared. Right, so there are a couple of ways to go here. If you're in a hurry, what you're probably going to do is this. Square root both sides and get 2/3 a. X is less than 2/3 of a. But look up at the graph up here. And that's not right, because that's telling me, for example, here, that it's all of those x values there. So something's going wrong, and what's going wrong is that I'm not thinking about positive and negative number situations. So I'm going to do this quite slowly on the next slide. So just see if you can pause and work out what I've done wrong on purpose, and see if you can fix it up. You might want to either draw a graph of something or use an underline. Okay, so here's what I'm trying to solve. I've got x squared is less than 4/9 a squared. Now often when you've got an inequality, a good thing to do is just to stop and change it into an equality and see what's going on there. Now if you do that, you'll if you're watching this video and you're doing excellence questions, notice pretty quickly that I need to think about the positive and negative square roots of that side, and that's going to give me my critical values. So we've got x is equal to negative 2/3 a and 2/3 of a. So let's whack those onto a number line and see what's going on. We've got 0 here, 2/3 a here, and negative 2/3 a here. So when will x squared be less than this amount here? Well, it's going to be fine if x is in there, but it's also going to be fine for those values there. However, when I'm back here, for example at negative a squared, negative a, write some of this down. So if I'm back at negative a squared, that gives me a squared, and that's too big. So this bit in here is not in my solution set, and neither is this bit here. So my answer is x between 2/3 a and negative 2/3 a. So that's when the function's decreasing. There's one other way to look at it that I think will help some of you, and that's using a little graph. So let's just graph x squared. Right, so this is just y equals x squared, and we want it to be less than this number here, which is 4/9 a squared. So we can mark that in on here. So here we've got 4/9 a squared. And I think looking at it like that, it's pretty clear that the x value here is going to be 2/3 a. And by the symmetry of the graph, you can see that it's negative 2/3 a on here as well. Alright, so lots of different ways to think about that. Main thing is that you get your final answer as x between those two values. Okay, thanks for watching.